Hi guys, welcome back to Pypro versus YouTube channel where curiosity meets the code. Today we'll be discussing about how to create real-time system utilization monitoring with Plotty. But before that, we'll be checking the packages pre-installed in my system. So the first command that I'm going to execute in command prompt is pip list, where you can see all the packages with the versions so I can give a look about what package is what version and update it accordingly. So you can take a look onto your packages. If not installed, please do install it. You can just Google how to install and there will be a command for that to execute in command prompt. Another command to check for all these is pip freeze, which gives a similar output where packages with the version will be mentioned. So let's get started with the code, starting with the modules required to run this program, which includes import psutil. So this line imports psutil module, which provides the function for retrieving system utilization data such as CPU, memory disk, and network usage. And we also have import plotty.graph of objs as Go. Here, plotty.graph objs module is imported as Go. This module contains classes and methods for creating interactive plots using plotty. And we are also importing threading which provides tools for working with threads in Python, allowing for concurrent execution of tasks. And we also are importing time, which provides various time-related functions, including utilization for pause execution with time.sleep. Moving on to the code. Moving on to the initial part, we have the lines that emphasize list to store the collected system utilization data for the CPU storage. So if you want to store any kind of data, we have initialized prior itself, such as for CPU data, memory usage is memory data, for disk usage, disk data, and for network sent and received, we are having network sent and network received respectively. Let's move on to the first function of the program, which is get CPU usage. So here you can see df get CPU usage. This line defines the function name get CPU usage, which will continuously collect the CPU usage data, and we have a while true loop. This line begins an infinite loop, ensuring that the function continues to collect the CPU usage data indefinitely. And we have CPU data dot append piece to CPU percentile interval 1 within the loop piece to CPU percent is called to obtain the current CPU utilization as the percentage. This value is then added to the CPU data list. The interval parameter specifies the time interval over which the CPU usage is measured, and we have time dot sleep of 2. So here we are actually making time dot sleep before collecting the data. This ensures a delay between successive data points. Before collecting any other data points, it will take a rest of 2 seconds. Moving on, we have get memory usage. So here you can see we have a module of get memory usage, and the same goes here also as the previous one. We have while true loop, and we are also giving memory data append psutil dot virtual memory percentile, and again before collecting any other data point, it will sleep for 2 seconds. The get memory usage, the get disk usage follows the same pattern, the same code, the same sleep time. So we'll move on to the next definition of get network usage. So here, as you can see, firstly, we are defining a function of get network usage, which continuously collects the network usage data and we have net is equal to pstool. We are also giving while true loop. Net is equal to pstool.net.io counters. Here pstool.net.io counters is used to retrieve network input statistics as name tuple. This function provides information such as bytes and sends and received over the network. And we have network sent data append net byte sent and the network received data append net byte received. So here the bytes sent attribute of the net tuple represents the total number of bytes sent over the network and the bytes received respect represents the total number of bytes received. These values appended to the network sent data and network received data list respectively to store the network data again. A time sleep of 2 is also given. And moving on to the next, we have threading dot thread and like these threading the thread functions repeated 4 times. These lines start separate threads for collecting the CPU usage, memory usage, disk usage, and network usage data. Each thread runs its respective data collection function. The daemon is equal to true argument indicates that the thread are daemon threads, meaning they will terminate when the main program exists. Moving on to the next part of the program, which is creating plotty figures. We have CPU dot figure given and the title, the x-axis, the y-axis have been figured out. For CPU figure, we have the same for memory figure, disk figure, network send figure, network receive figure. These lines create plotty figure widgets for visualization, the system, utilization data. Each figure widget represents a specific aspect of the system usage, like CPU, memory, disk, network send, or network receive, with the appropriate titles and access labels. So let's move on to the next function, which is the update figure. So here while it starts with while true loop with CPU figure dot batch update, memory figure batch update, this figure everything is here updated and traced. So here you can see memory dot figure add to trace and all. This function update figure continuously updates the plotty figures with new data. It iterates through the each figure widget and updates it as at least the data for CPU, memory disk, or network sent and network receive. It then sleeps for 2 seconds before updating the figure again. And here you can see that threading the threading dot thread. This line starts a separate thread to execute the update figure function concurrently with the main program. Moving on, we have a part to display the plot of every map. So here you can see we have been displaying the CPU figure dot show. Dot show is a function that shows the plotting. We have CPU dot figure dot show, memory dot figure dot show, and disk dot figure dot show, and even network sent is also shown. Network receive function also shown. So let's move on and see the output of the program. So as usual, I'm going to go to where the file is, copy the name of the file, open the command prompt in the same window, and Python space file name dot py. So it opens a Chrome window, and you can see there are multiple windows or taskbars opening, and you'll have each network sent, network received in one of the windows appearing, and it's updated every 2 seconds. Thank you for watching. If you have learned something from this video, please do like, share, and subscribe to our channel. Thank you.